All right, folks, so here's our notes for 2.2 B, which is one-sided limits and limit properties. This is going to be a lot easier than last time, so it's kind of nice to have a little step down. So first of all, this is much better than having to write all these down. These are a lot of common sense, but what it says is these are the things you can do with limits, because we just practiced finding a lot of limits, right? So if you ever have the limit, and C is for constant, of B, another constant, times a function, what you're allowed to do is pull that constant out in front and just take the limit of the function. If you ever have a limit of two separate functions added together, you're allowed to, or subtracted, you're allowed to split them into the limit of the first and the limit of the second. That would be like if I had limit of, let's say x approaches 0, of 2x squared plus 3x, right? That would be like taking, I could not only split them because of this plus sign, but I could also pull out that 2, I could pull out that 3. It basically is saying you can do many algebraic things to limits. And then I could even do something with the power, because this is the power rule. So I can pull a constant out in front if it helps me. I can split up things inside limits and take their limits separately. If there's multiplication, I can take their limits and multiply the answers, because remember, a limit is a number. If there's division, you're allowed to split it, except you have to make sure the bottom is not going to equal 0, because you're still not allowed to divide by 0. And if you have a power, you can take the limit first and raise the number to a power. Sometimes it's easier that way. So these problems are really easy. Notice these are all limit of 8, so you don't have to find it. It says the answer to the limit as x approaches 8 is negative 9. The answer to this different function as x approaches 8 is 2. So basically what it's saying is if you saw this and were asked to take one big limit, you're allowed to take 2 times the limit of f of x, which is negative 9, minus 12 times the limit of h of x, which is 4. And this stuff is really easy. So negative 18 minus 48. And then I'm going to go through and just put the answers on here that you can pause and check your work in a second, okay? So I don't think I have to go through every one of these. I'll finish up down at the bottom with you, but take a minute, pause this right now. You didn't pause, and do the rest of these just by plugging this stuff in. You can check if you did it right in a second. But two things I wanted to note. If the limit as x approaches 8 of 6, since it doesn't have an x on it or an h of x or anything, it's still just 6. The other thing is, I don't know if you noticed, I left off a parenthesis. So when you add it in, you want to do this part first. Good old PEMDAS. Alright, so there's the top part. Nothing crazy there. Just plugging stuff in. The bottom part, you just got to be careful to make sure the denominators aren't equal to 0. Otherwise, it's pretty much the same thing. Just make sure when you check these limits should be below, but that's hard to do that on Word. So anyway, just as long as they're all 4s, you can actually use these answers to limits. Alright, so try to keep doing that. Pause it and then check your answers. Okay, so for this middle example, I just plug the numbers in, and then you can't add fractions unless you have common denominators. So I multiply top and bottom by 10 here, and then I could add them and make 71 out of 10, or over 10. And then this one was super easy multiplying. So now to the bottom, when we have the powers going on, okay, you can try those out and then pause it and then start it back up and see if you did it right. All right, here's the last two. So when you plug it in, just cubing 5 is 125. You do the inside first and then raise it to a power, because that's our power limit property. And then square root is also the same as 1/2 power, so it follows the same rules, meaning I can do what's inside first and make it a positive 4 and then square root it and get 2. All right, let's move to the back. Now we're doing the one-sided limits. You know how normally when if a limit was going to exist, it would have to be the same number from both sides squeezing in? So we said, like, in class, we said this step function wouldn't have a limit here at x equals 1 because it's a different number from the left than it is from the right. Well, we mathematicians didn't like having to say does not exist so often, so we made a new rule. We're like, hey, if you want to, you can take the limit just from the right side or take the limit just from the left. And if you notice, it's really tiny down there, but it looks like an exponent of a plus sign. When I think of that, I think, because sometimes people get confused on is it from the right or is it from the left. When I see a plus sign there, I think of a number slightly bigger than a. And here, when you see a minus sign, you want to think of a number slightly smaller. So if you had like a 5 there, you want to think of 5.00000001. If you had a 5 here, you want to think of 4.9999999. So a tiny bit smaller. So you're approaching from the left or you're approaching from the right. So this says, if you're taking a right-handed limit, it'll have that little plus sign, provided we can make f of x as close to L as we want for all x sufficiently close to a, and x greater than a without actually getting there. So same deal. You never get to that point, but you're talking about approaching it from the right or approaching it from the left. So really you just got to remember the plus goes with right, the minus goes with left. The only difference between these and normal limits is the time the function only needs to settle down to a single number on either side, either the left or the right. So basically, it loses that condition we had before that it has to squeeze the same number from both sides. Now it doesn't. So for example, I like the picture ones. These are awesome. So for example, if I read this, I would say the limit, this is f of x, right? The limit as x approaches -4 from the left. So here's x of -4. The limit as it approaches -4 from the left. I'm on the train. I'm riding it. Whee! Okay, what y value comes out of there? A 3. Okay. Because what's smaller than -4? -4.001. When you read this, f of -4, that means what really is the y value? Where's that dot? How high is that dot? It's also at 3. But then when you read this one, what's the limit as x approaches -4 from the right? So now I'm on this train, and I'm coming down here. It doesn't have to actually get to -4, because -4, if you plugged in a -4, it would jump back up here. But if I'm writing this down, it's approaching this height. It's getting closer and closer to a -2 from the left. So the actual point's at a height of 3. If I approach from the left, I'm at a height of 3. If I approach -4 from the right, I'm at a -2. So if I just asked you a plain old, what's the limit as x approaches -4, well, if these two numbers don't match, you say the limit does not exist. If those two numbers did match, I would have said it. Okay, so let's try it at -1. See how there's no jump here? I think you're going to see a lot more normal answers. So first, what is f of -1? It's saying what's the y value dot for -1? Here's the dot. It's at a height of 4. This one says, what y value does my graph approach from the left? So I'm hopping on the train. I'm riding it from the left. As I get closer and closer, what y value does it approach? 4. This one says, what y value does it approach from the right? So now I'm going from the right and seeing what y value do I approach. It's coming down closer and closer to a 4. Now if these two numbers are the same, which they are from the left and the right, then you can say the general limit as x approaches -1 is 4. The number it squeezes in on both sides. So whenever you don't see it with a plus, it's asking about both sides. If you see it with a plus or a minus, it's asking about one side. So you can actually give more answers this way. All right, so I'm going to pause it. I'll let you do these two, and then you pause it and check your answers in a second. All right, check out how you did. Hopefully you got from one side it's down, from the other side it's up at 5. If those don't match, you say does not exist. Here's a weird one. See how there's no dot there? It's an open circle. So if you ask me what is the height at 4 exactly, I'd say it's undefined because there's no height. But what's crazy is you can answer the rest of the questions. You can say what number does it approach from the left? 2. It never has to get there. What does it approach from the right? 2. And if those two numbers from the left and the right squeeze in on the same number, that's your limit. All right, let's move to the last part. All right, so for example 5, I'm asking you to sketch a graph that fits all these categories. So I think this is the easiest thing to do. Can you make a point when the x value is 2 and the y value is 1? Oh, that was easy enough. Now, this means the limit as x approaches 2 from the minus sign, it's the left, just slightly smaller than 2. The y value is going to be 1. So there it is at 1. So I can do anything I want from the left. That gets closer and closer to that point. The other one, when I come in from the right as x equals 2, it's down at -4. So 1, 2, 3, 4. So I have to do an open circle because when x actually equals 2, the closed dot is up here at 1. So I do an open circle, and then it doesn't matter where you go. I chose to go up. You could have gone squiggly or left or a straight line. So does that fit all three? From the left, you're up at 1. From the right, you're down at -4. And the actual point is up at 1. So there it is. Let's move to the last one. All right, so for our last one, kind of similar. We're going to graph this thing. And the first thing I see, at f of 3, it does not exist. So that means you're not going to have any points. You can't really put an open circle here because you got to see where it's going. But from the left, it approaches 3 at a y value of 0. 1, 2, 3. So it's going to approach here from the left. Okay. And from the right, it's going to approach 4. So I'm going to put an open circle in both of those. Now I don't want to draw the lines yet because I got to see what else is happening. At -1, we're up here at 2. Okay. At -1, it approaches, oh, we have a dot. So we have our dot at a height of 2. What does this mean? This means from the left and the right, it squeezes in on a height of -3 when x is -1. So if I go down 1, 2, 3, my graph, even though it's an open circle, it never gets there. It's going to squeeze in here from the left and the right. And the dots just float. This just is like a floating dot. This one can go off to the side then. So I want to make sure everything works. So first of all, do I have floating dot, -1, 2? Yes. Do I have no value at a 3? They're both open circles, so there's no existing number there. Do I approach 0 from the left of 3? Do I approach 4 from the right? Yep. So it all works out. All right. Hope this stuff makes sense. It's a little easier than last time. You just can do one side at a time. All right, people. Later.